In this video, we're going to cover two learning objectives. Letter A, we're going to make or interpret a dot plot or stem plot to display small sets of data. And B, we're going to describe the overall pattern in terms of shape, center, and spread of a distribution. In particular, we're also going to identify if there's any patterns that deviate from it in terms of outliers, gaps, or clusters. Now, what is a dot plot? Each data value is shown as a dot above its location on a number line. So if you have some raw data, you're going to plot it out and look at the shape of that. When you examine the shape, you're going to look for things such as the shape could be symmetric, skewed to the right, or skewed to the left. If it's symmetric, you're going to see some type of pattern that looks equally balanced, such as this. If it's skewed to the right means you're going to see a tail forming on the right side of it. So this is where you're going to see a tail show up. If it's skewed to the left, what you're going to see is the data starts more on this side and you're going to see a tail more on the left-hand side. Now the shape could also be some type of mode to it. There is unimodal, bimodal, or multimodal. If it's unimodal, you're going to see one hump in the pattern. If it's bimodal, that would mean two. So you might see something like this. That would be considered bimodal. And then multimodal would be more than, obviously, two. So it could look something like that, would be multimodal. The other three things you're going to look at is, one, is there any outliers? Are there any dots that deviate from the mean pattern? We're going to talk about the center. The center, we typically talk about either the mean or the median. The spread is how spread out the data is. Again, typically we use range, standard deviation, or IQR for this. So you're going to want to remember the acronym that this spells out is SOCS. That is SOCS. We're going to say a lot in this chapter. Don't forget your SOCS when you have to describe a distribution. This is the perfect segue. Again, we just talked about don't forget your SOCS. Again, that just means shape, center, spread, and outliers for that. What do you talk about for shape? You're going to talk about the skewness of it, if it's symmetric or skewed right or skewed left, and how many modes it may have. Again, for outliers, we're going to look at the upper and the lower fence, basically meaning what's an acceptable range of how high we can go in the data and how low we can go in the data before it really doesn't belong in the data set or it's considered an outlier. Other things, when we talk about outliers, it's important to talk about any clusters or gaps that are obvious in the data. In terms of center, the value that generally describes the distribution, again, I mentioned before, either mean or median. And there is going to be one that you want to use over the other, but it's all based on the shape. So when you look at the shape, if you see that it's skewed, what you want to use is actually the median in your description. If you notice that the distribution is symmetric, then what you could use is the mean. Then wrapping up with spread. For spread, we're either going to use the standard deviation, or it says here the 5-number summary, but really the 5-number summary, we're going to talk about interquartile range. We would use that more. Or we would actually just talk about the standard range in the data, which is just your maximum minus the minimum. The way you want to connect which spread to use is if we choose to use the mean for the center because it's symmetric, then that means that we could actually use the standard deviation, or the range would be acceptable measurements for that. However, if we had chosen that we're going to use the median for our data for the center, then what you want to end up using for that would be the IQR for the spread. So those kind of partner together in what you would use hand in hand. So let's go ahead and look at an example here. Here we have a dot plot put together. It looks like a variety of students were surveyed and asked how many siblings you have. By the way, I could see how many students were in this data set if I counted each dot. Each dot represents each person. Now if you look at the shape of this distribution, I'm just going to kind of put a little flow of a line across it. And if you look at that, it does not look symmetric because it's not equally balanced. You see the tail of it on the right-hand side. So because of that, we call this skewed right. Now, for the measure of center that you want to use, because this is skewed right, the mean is actually going to be overinflated. These guys right here, we might actually consider some potential outliers. So let me identify them first. Two potential outliers would be those reporting having siblings of 5 or 6. So we should highlight these two dots here in our outliers. Now, if we were to compute the mean, we would tally up, for example, we would say 0 plus 0 plus 0 plus 1 plus 1 plus 1 plus 1. We would add up the value on each of these dots and divide by how many dots there are. So if we tally these up, we divide by 28, we would get 1.75 for the mean. But think about it, if we have some high values in there that really are kind of skewing the data to the right, they're going to cause the mean to be higher and overstated. So what we need to be cautious of here is not use the mean, but to actually use the median for our measure of center. Well, how do you find the measure of center? Well, if there's 28 pieces of data in here, we would say n, or our sample size is 28. The median is going to happen at the 14th and 15th individual. So because there's 28 pieces of data, there's no one right smack dab in the middle. So we actually do have to find the 14th and 15th piece of data. When you count up this direction, the 14th piece of data ends up being this last one here. The 15th ends up being in here. So we have, for the median, the 14th is a 1, the 15th is a 2. Remember, we take that and divide by 2. So the median for our data set is 1.5. Now, the last thing we should use, again, this is a skewed distribution, so we probably shouldn't use the range. However, we haven't talked about how to compute the IQR or standard deviation yet. So for as of now, describing the spread, we will use the range calculation. And we will just say that the number of siblings varies from 0 to 6. And once we talk formally about IQR and standard deviation, then we would use those instead when it's appropriate. Now, we just saw an example with a dot plot. Well, how did they make that dot plot? It's very easy. It's one of the simplest graphs you can construct, and all you need to do is this. On the horizontal axis, you make a number line, and you label it with the variable name that we're dealing with. Here's some data that you don't have in your packet. It just says the number of goals scored per game for the U.S. Soccer team for the women, so we just labeled that. This is the data for all of the games they played in 2004. Then you're going to scale the axis from the minimum to the maximum value. Make sure your tick marks are appropriately scaled and spaced out. And then you're going to mark a dot above the location on the horizontal axis for each value. So you literally just go through and say, I need to put a dot for 3. You put a dot at 3. You go to 0, you put a dot at 0. And you do that for all that data. When you do, your dot plot's done and you're ready to analyze the results. So let's look at an example in our packet. We have the NFL example. Here's the number of turnovers for the 2009 Oakland Raiders football team during 16 regular season games. This is how many turnovers, there's 16 pieces of data. To create a dot plot that displays the distribution, and then we'll talk about the SOCs, the shape, center, spread, and outliers. So the dot plot on here is going to actually look like this. We have the turnovers labeled, we have the numbers, and we just recorded the data. So for the 3, we put this first dot. We have a few more 3s, so we added some more dots. Now, let's talk about the shape. If I follow the pattern, it looks like here that this one is somewhat skewed left. Now, in statistical analysis, it's actually okay to say somewhat skewed. If you don't think it's sharply skewed or very precise in that, and you think it's just kind of, somewhat's always a good word to add. Now, it is somewhat skewed left, so technically the best measurement to use would be the median. If they asked us to find the mean, we could. For the mean, we would just add all these up and divide by 16. For the median, there's 16 pieces of data, so it means we have to find the 8th and the 9th piece of data. When you find the 8th and the 9th piece of data, they both fall in under the 2. Therefore, we can just say that the median here is going to be at 2. Again, we haven't talked about the IQR, which is what we should use because it has a skewedness to it. Let's just do the range right now. Range is just going to be max minus min. So for that, it's 4 minus 0. When you compute the range, you need to actually do the final computation. If you said it was 4 minus 0 on a free response question, and you didn't actually say this equaled 4, they would not give you full credit. You must also show this calculation even though it's incredibly obvious that it would just be 4 minus 0. Now, in terms of outliers, there really appears to be no obvious outliers in this case. The last thing to keep in mind are there any gaps in clusters that are obvious? In this, there aren't, so you don't actually need to mention that. But be really careful. If you have a data set, for example, when you look at the dot plot, it looks somewhat like bimodal. There you have some gaps or some clusters. We have clusters here and here. We have a gap in between here. So you would need to mention that, otherwise you would lose some points. Now the next type of graph beyond a dot plot would be a stem plot. What a stem plot does is it gives us a quick picture of the shape of the distribution while including the actual numerical values. It's basically a dot plot, but with numbers. So I almost kind of like the stem plot better. Let me just show you this first stem plot down here with this data. Here we have responses from 20 female AP statistics on this question. How many pairs of shoes do you have? These are the 20 responses. So to make the stem plot, what you're first going to do is identify your stems. And in this case, it's going to be the tens position. So we've labeled from tens all the way to the 50s. Then you're going to add your leaves. It's very important that when you clean this up, you're going to notice the leaves as they were added right here for the 50s are not in numerical order. You always rewrite them in numerical increasing order. And notice they have the repeats shown there. So this here is the stem plot. Also, you want to have a key on how to read that. So here you would just say, for example, 4/9 represents a female who reported having 49 pairs of shoes. There's two other types of stem plots. There's a splitting stem and a back-to-back stem. The splitting stem is that values having leaves through 0 through 4 are placed in one stem, while values ending in 5 through 9 are placed in another. You might do a splitting stem because it's going to be easier to see gaps in clusters. And if you do a basic stem plot, if it's hard to really read the data and really look at the pattern, that's why you might split the stems. And we'll look at an example in a little bit. A back-to-back stem plot is when you use it to compare common distributions back-to-back. Maybe you sample some girls and you sample boys about the same thing about their number of shoes. If you make that back-to-back stem plot, we'll actually see that on the next slide. So right here is a really good example of the back-to-back stem plots. So here's the original female data, and then they did ask the males the same question. We see the females here and the males here. It's very nice to see the data laid out this way. It's clear that the females, by far, have more shoes. And one important thing you want to take away from noticing these stem plots is they did not skip any stems. So do not skip stems. Otherwise, it's not a correct stem plot. So for example, right here at this 40, there's no data for either the males or females, but you can't just eliminate that stem plot because you need it for the accurate spacing. So for our notes, let's look at this example. Who's taller? Which gender is taller, males or females? They took a sample of 14-year-olds from the United Kingdom at a certain particular website school. Here are the heights of the students in centimeters. We have the guys and we have the gals. They want us to create two stem plots for the male heights and one with split stems. So I'm going to go ahead and let's just do a standard plot for just the males. So what I would do is this right here. If you look at the males data here, it looks like we have from 150 up to 180. So I'm going to choose these for the particular stems from 15 to 18. And then for the leaves, we're just going to look at the last digit for that, and we're going to put them in increasing order. So this is a great stem plot representing the male heights. And then again, I'm not going to forget the key or my legend. Now they want us to create one with split stems for the guys. So here's the difference for that. On the split stems, what you're going to see these two right here at 1 through 4 and the one at 7 through 9 in different spots. So notice the 15 was split up. So that's where the 1 and 4 go, and then the 7 and 9. These stem plots are actually very easy to read. Be careful. This right here, this particular piece of data, would represent a boy at the height of 167 centimeters. What if they asked us to create a back-to-back stem plot comparing males and females? What we would do with that is take the guys plot that we originally had, and this one here is the split stem. So this is it split for the males, and then we would do the same thing and add the females on the other side. Notice their order is in increasing order, but backwards. This is a great picture of looking at the two different distributions.